find the observed significance levels. And so when we write these, assume here that the index 1 is in the numerator. Okay? So whenever we write N1 and N2, assume that index 1 is what generated the F value 2.81. All right? So what do we have here? Two-sided test. We need to look up the areas here. So at F of 2.81, we're definitely in the right side of the distribution. Okay? And so that magnifying a right-hand side of an F distribution, what are our numerator degrees of freedom? 15. Denominator degrees of freedom 17. All right. Now going from page to page or subtable to subtable, staying in column 15, row 17, find the two values between which the calculated value 2.81 falls. You should find value 2.72 that determines the right-hand area of what? 0.025. Then you should find a value 3.31 that determines the right-hand area of 0.01. Agreed? Our 2.81 is in here. So our p-value is 2 times the probability of an F with 15 numerator and 17 denominator degrees of freedom being greater than or equal to 2.81. So when we look up that area, we're finding half of the p-value. That probability is bounded below by 0.01 and above by 0.025. Double it, so this reads as p. So our p-value is between 0.02 and 0.05. Agreed? For our right-hand test, F is calculated at 7.62. We have sample size 14 and sample size 10. So for this application, our degrees of freedom are 13 and 9. The application of comparing two variances. Okay. We're going to do right-hand test only. So our p-value is not multiplied by 2, but is the probability of an F value with 13 numerator degrees of freedom, 9 denominator degrees of freedom being greater than or equal to 7.62. All right, so go page to page, column 13, row 9. Now you could write all the values in there and draw them all in if you wish, but what we have is 6.15 is the largest value you can find, correct? And it determines the right-hand area of what? 0.005. So that means the best we can tell is that our p-value is what? Bigger or smaller? 7.62 is over here. So the area to the right of this is smaller than 0.005. So from your table in this textbook, p less than 0.005 is the best we can do. Okay? So if you write something else that might be true, but from your textbook you can't confirm that. Right-hand test, F is 3.21. Our two sample sizes are 8 and 7. So our p-value is not going to be doubled since it's right-hand test only. It's going to be the probability of an F with what degrees of freedom? 7 and 6, in that order, yes. Probability of F with 7 numerator and 6 denominator degrees of freedom being greater than or equal to 3.21. All right, so again, look at the tail of the distribution with F. It's 7 numerator, 6 denominator degrees of freedom. So work page to page. So what we have here is what? .01, determining a right-hand area of what? 0.1. And the next value is 4.21, determining a right-hand area of 0.05. And we are in there. All right, it's a right side test. So we're not doubling anything. Okay, so that our p-value is smaller than 0.1, but larger than 0.05. And if you have to draw the picture to get it's right for F or for any of the test statistics, go ahead and draw the picture. I'd rather have you draw the picture and get it right than think you don't need the picture and miss it. Now, in either of these two cases here, if they were two-sided tests, we would double it. So up here, if it were a two-sided test and we were this extreme, you'd report p less than 0.01. Okay, it could be so extreme that 0.005 is maybe accurate, but we can't tell that. Okay, so if it's a two-sided test, make sure and double this so that it would be less than 0.01. If this were a two-sided test, it would be between 0.1 and 0.2. All right, now we have a two-sided test. We calculated an F value of 1.24, and we have our degrees of freedom, our sample sizes of 15 and 12 respectively. Okay, so that tells me my p-value is going to be 2 times something, because it's two-sided, 2 times the probability of a calculated F with 14 numerator degrees of freedom and 11 denominator degrees of freedom. Probability of that is greater than or equal to positive 1.24. That's what I need to look up. So go to the row for 11 degrees of freedom, columns for 14, to find the two values between which the calculated value 1.24 falls. When you start going in this, your very first lookup, you get 2.18, determining a right-hand area of 0.10. Agreed? 1.24, we're over here. So kind of like what we talked about on the t-table, we fell off of the left-hand side of the table. That's kind of the analogous thing here. Okay? So the best I can do here is what? That the probability associated with 1.24, the right-hand probability, is bigger than 0.1. Okay? For the p-value, it would be twice that, greater than 0.2. So 1/2 p over 2 is equal to this quantity, so 1/2 p we know is bigger than 0.10, so that means our p-value is greater than 0.2, and that's the best we can tell. Now, if you wanted to put a upper bound on that of 1, that's fine, but not needed. So, or you could write 0.2 less than p less than 1. That's all we can tell. We know less than 1 because it's a probability distribution. If it were a one-sided test, you would just report p greater than 0.1. All right, so here I drew out the whole distribution so because we were so extreme here. It wasn't necessary to get all the finer graduations down here because we were so close to 1.